All right, I can start. Hi, everyone. I know we have just about an hour, so my presentation is about 45 minutes, and then we have some room for questions. So I'm going to today be speaking about a masterclass in maternal and infant gut health in that first 1,000 days. All right, so I'm going through my outline of the talk today. So I'll talk about the gut microbiome, what it is, and the first 1,000 days and how it leads to gut immune training for lifelong immune development and health, and why is it important. And then I'm going to go into the healthy microbiome, the features of a healthy microbiome in an infant that is very different, and in fact, the opposite of what's healthy in an adult. And I'll show you some differences there. And then I'm going to talk about the MVPs in a child's gut, basically bifidobacterium and HMOs and the roles that they play. And then I'm going to dive into some off-course gut disruptors and how they may impact the immune system and the gut microbiome of the child for their lifelong health, and then some microbiome recovery and approaches. So I'll dive right into it, the gut microbiome. Most of you here will already know that the microbiome, basically I'll jump kind of like further upstream to what is even the microbiome, because oftentimes people think of the microbiome and only think of the gut, but there are many different sites. And it's important to realize that it's not just the gut, it's the skin, the oral, there are many sites. There's the vaginal microbiome that I'll talk about a little bit as well, this respiratory microbiome. But today I am focusing on the gut microbiome, and because it's the most well-studied and the most accessible from stool samples. And we do have a stool test that can help you understand the gut microbiome better. There are numerous functions that the gut performs. They digest nutrients and produce metabolites that digest for digestive health and gut lining health. It really forms our immune system, our nervous system, and so much more. So, you know, when you hear about the 38 trillion microbes in and on us, they're all basically various sites. And they're not only bacteria, but they're also fungi, viruses, parasites, archaea, in and around and within our bodies. And everyone has a unique microbiome, sort of like a fingerprint. And, you know, over the years, there's more and more research coming out on the gut microbiome. There are some clear patterns emerging on what's normal, what's healthy, and what's abnormal and unhealthy, basically features of healthy versus unhealthy microbiomes. So the term dysbiosis really refers to when the microbiome is imbalanced and when there's a severe kind of imbalance between the beneficial functions as well as the unhealthy functions in the gut. So then, you know, you might want to have the question on where does this microbiome come from? Where do you get it from? Well, science have shown that baby is actually pretty sterile in the womb. There's no, there may be some exchange, but the baby's gut is not really colonized by mom's gut microbiome in the womb. They actually first get colonized with the mom's microbes through the vaginal canal when the mom is laboring. So you see these lactobacillus bacteria here that should be colonized from mom's vaginal canal. And then some fecal fluid, what you saw just now is the fecal fluid during labor that babies swallow on the way out during birth and labor, which is actually, sounds gross, but it's actually really healthy for the seeding of the baby's gut with mom's gut bacteria. So the Y's here are, you know, should be the bifidobacteria from mom's gut. So babies acquiring that on the way out and be seeded with it too. However, babies are also seeded with bacteria from the immediate environment. So whether it's hospital, whether it's home, and who's around the birth, doctors or family members can influence the seeding of the baby's gut. And ideally, as that you saw earlier, what was acquired first was the mom's lactobacillus from the vaginal canal, and then certain strains of bifidobacteria from the mom's gut. And I'll explain why this is so crucial and important. And then over time, in the first 1,000 days of life, especially the first few months of life, the mom is continuing to magically transfer her beneficial gut bacteria to her baby from her gut through breast milk. Now I'm going to pause on this video for a second. The purple triangles that you see here are basically human milk oligosaccharides. I'll call them HMOs that makes up a third of breast milk. So HMOs are indigestible fibers that goes through the baby's gut, and they actually feed the beneficial bifidobacteria in the baby's gut. So again, the baby can't digest it. It's actually food or prebiotic fibers for the beneficial bacteria and turns it into energy and a short chain fatty acids that's really important for baby's gut lining called acetate. So it really then, this begs the question of what happens if the mom's gut was depleted in bifidobacteria. Will that have transferred through vaginal birth or not? And then through breastfeeding. So mom, aside from HMOs, is also continuing to transfer her gut microbes. So these green dots here are equivalent to the bifidobacteria if mom had it, that continues to transfer through breast milk. So what happened if mom didn't have it? What happened if the baby was formula fed? What happens if the baby was C-section born or there were antibiotics involved during labor and birth and in early life? What happens to all these beneficial microbes? We'll talk about that soon. And so I'm going to jump into the immune training the first 1,000 days and why that's a critical window for lifelong immune system. So because the baby is born, is sterile in the womb, they're basically born without an immune system. As you may have heard, 70 to 80% of our immune system lives in our gut. And so if baby doesn't have their gut microbiome at birth, basically they don't really have an immune system. And this is also why their gut barrier is highly permeable. So they're very susceptible to to infections and things like that. However, the breast milk of the mom, the antibodies in the mom's breast milk is what protects the infant. But also this balance of beneficial versus unfriendly bacteria of microbes are what trains their immune system. So ideally, baby is protected by 50 to 90% of specific strains of bifidobacteria. And I'll go through what the 4 strains are, the core 4 that we want to see. And then ideally, they're exposed to a wide variety of environmental, dietary, and animal microbes to build robustness and resilience. So you want that diversity to be low in the first 6 months of life and then shoot up really high after. And atopic march symptoms like eczema, food allergies, and asthma are basically the first signs of immune dysfunction in babies, because a normal developing immune system of an infant should be able to respond to environmental, dietary, and respiratory allergens. So eczema is basically a sign that, usually that's what in the allergic march progression is what the baby gets between 3 to 6 months. And then food allergies around 6 months to 2 years old. So it's a sign that the baby's immune system was not trained correctly in the early days. And so basically the microbiome development, as I mentioned, occurs between birth and, the first 1,000 days actually starts in conception until the baby is about 2+ years old. And there are a few key transitional periods. So at birth, as I mentioned, when what microbes see the baby's gut at birth does matter. Vaginally born babies and C-section babies have a different gut. And between 1 to 3 months is that really crucial time period for immune training and is associated with decreased risk of atopic march. And then the 4 to 6 months period with the introduction of solids and allergens is another crucial time point when a lot of dietary diversity comes into the baby's gut and changes that development window as well. And between 2 to 3 years old, they're starting to eat a typical adult diet. And literature has it that between, their gut between 3 to 5 years old is then similar to an adult's microbiome. And once established in the first 1,000 days, the microbiome of the child isn't going to be easy to change. So a 5-year-old's gut is not impossible. You can still change it. It just takes a lot of dietary and supplemental efforts to change it compared to when the baby's 2 months old or a year old. It's much more malleable. So I think this point is really important to note. And this is why we focus on the first 1,000 days as a possibility of gut modulation and course correction if we do see any imbalances to really prevent and even reverse chronic conditions. And here I really want to emphasize this microbiome seeding really does shape the trajectory of the microbial ecosystem and the overall health through this gut immune axis. There's this really nice chart that we at Tiny Health have reproduced from the Dogra paper that shows this kind of how different functions change over time in the first 1,000 days. And I'll start with how, sort of why it's really profound what microbiome families dominate the infant's gut in the first 6 months, first year of life, and how that really rapidly changes over time. Bifidobacteria is very influenced by breast milk and vaginal birth and the right diet and fiber, you get some Enterobacteriaceae really high at birth, but it comes down really quickly and goes down. So, and Bacteroides are associated with a vaginal birth. You really don't see any Bacteroides in a C-section born baby. And so then there's a concept called microbiome maturation, which really maps with diversity. So at Tiny Health, we've created a maturation score where we can predict an infant's microbiome within 1 month of accuracy of age. So if the infant's microbiome age is 2 months old, is usually pretty accurate within 1 month. So sometimes when diversity is too high too quickly, that can be affected by solids that are given too early to an infant or maybe formula feeding. The diversity of the baby could be prematurely accelerated, which changes their maturation profile. And then this is also how it impacts their immune training, as I mentioned earlier. So there's some breast milk antibodies that comes in pretty early on. This graph assumes that the baby's weaning around 6 months, so you can actually influence the infection susceptibility if you prolong breast milk, because you are giving your infant more antibodies over that time. Bifidobacteria also has a role to play. The combination of BIFs and Enterobacteriaceae. Enterobacteriaceae are your E. coli type bacteria. So the right balance of BIFs and E. coli also has that role to play to train a baby's immune system over time, and where then that innate immunity takes over. How do I notice? I'm not a doctor. I'm not a microbiologist. I actually have a personal story for why I started Tiny Health. It was really my quest to take control of my family, my 2 babies' gut health. So my story is that I had 2 wildly different birth stories. My first child was born by a C-section birth, and she ended up having colicky symptoms, issues napping and sleeping at night. And then at 6 months, she did have eczema and a sesame allergy. And then as she grew in toddlerhood, she was gluten, dairy sensitive, constipated. So a lot of gut issues. So this is where I dove into the literature and found the connections between early life microbiome and immune-mediated allergic diseases. And then 2 years after that, I was pregnant with my son. I was worried about a second C-section and how that would affect his gut and his symptoms. But thankfully, I actually had a magical home VBAC, so home birth, home vaginal birth with him. And he didn't have anything that his older sister has. No eczema, slept so well like a baby. So there are measurable difference in their health. And it goes back to this paper by Stockholm, which shows the distinct differences between the microbiome community that seeds baby that is very different from a C-section and a vaginally born baby. What's remarkable about this paper is that by 1 year of age, most C-section babies do look like vaginally born babies. So the good news here is that you can modulate the infant gut and reduce risk. The purple graph is where there's something called the C-section signature in this paper, where you can basically see a subset of microbes that look like antibiotic resistant bugs that colonize baby's gut in early life. So there are a subset of kids or babies who retain that C-section signature after 1 year, and those babies had a 3 times higher risk of developing asthma and atopic march. So when I was, when I was pregnant with my son, I was, really curious about, what his C-section signature was. If I had a C-section, again, obviously I didn't have that. I started Tiny Health a week after my son was born because I felt like, this immune gut connection in early life is so crucial. I don't understand why there wasn't a gut test for this group for moms and babies, and really felt like, I wanted to know, and I'm sure a lot of other parents and practitioners also wanted to know this important development. And I did want to mention one thing here. So what I did was also before as I was researching tiny health and creating tiny health, I did a pregnancy gut test and a vaginal gut test on myself with my son. And what I found was that I actually didn't have the beneficial bacteria I was supposed to pass on to my infant. I didn't have any bifidobacterium. And so reading literature, I mean, if mom didn't have it, then possibly even with a vaginal birth and breastfeeding, I breastfed my son for 2.5 years, I may not be able to pass on bifidobacteria to my infant unless dad has it or sibling has it. And so I knew that even with the vaginal birth, I may not have, my son may not have colonized those healthy bifs. And so I had to supplement my son with a specific strain of bifidobacteria for just about three weeks, because I also knew that from literature there is a danger of oversupplementation, which I'll go into a bit later, which just shows you, like, if I had to test before my son, before in early life, if I had tiny health, I would have tested him and known if I actually did manage to pass on the BIFs to him or if he needed precise supplementation. I'll dive into a little bit of the signatures of a vaginal birth I mentioned earlier. So in vaginal births, we do see more bifidobacteria because, as I explained earlier, that should have colonized baby's gut from some fecal fluid during labor, passing through the vaginal canal, and then through continued breastfeeding. We see Bacteroides only in vaginal births. We don't see it in C-section babies. So that is a very clear signature. And, we sometimes see lactobacillus from mom's vaginal microbiome seeding baby, and then it quickly disappears because lactobacillus is one of those bacteria that isn't supposed to colonize in the large intestines. It really lives upper tract in the small intestines. So with C-section babies, because they're not bypassing the vaginal canal, and they're also exposed to antibiotics during the operation, they tend to acquire more skin microbes or oral microbes from the mom, staphylococcus, streptococcus, clostridium, which is antibiotic resistant, usually acquired from the hospital environment. So this maps to a different risk profile for the infant. And so earlier I mentioned the Stockholm paper. I really, was inspired by that paper to create Tiny Health. And I really wanted to see the C-section signature in babies. And so the C-section signature really just compares the level of bacteria typically seen in babies born via C-section versus those vaginally born and the ratio of it. So, this is a surprising fact. So we've now served, as I mentioned, almost 30,000 families, and a lot of them have infants. And in about 30% of vaginally born babies, they also have the C-section signature. So, and they have eczema or colicky symptoms. They have allergies or cow's milk protein allergy. And sometimes parents come to us and tell us we thought we did everything right. We had a vaginal birth. We're breastfeeding exclusively. Why is my infant having these eczema symptoms? And when we do have mom's sample, mom did not have bifidobacteria. Remember, that was my case as well. So there is a strong connection between mom's gut, even mom's vaginal canal, and baby's gut. And even dad and older siblings. I'll come to that a bit later. So the whole family's gut health matters for the infant, right? Not just the birth and the feeding mode. So it's very surprising, but about 30%, this impacts about 30% of the babies that we see. And then I can talk a bit about formula feeding and the gut microbiome. Just scientifically, we see that breastfed infants have lower diversity to begin with, and then post-weaning, diversity ticks up. And in adults, you want high diversity. In infants, in the first 6 months, you want very low diversity because their sole job is to process and digest the HMOs in breast milk. So their guts are very simple. They're not eating a diverse diet yet that's influenced by different culture and climates and countries and things like that. The first 6 months of the infant gut is pretty universal. So there's a universal healthy microbiome in the first 6 months of life. And then, so when babies are formula fed early life, or maybe even exclusively, we do see higher diversity in that infant's gut, which again, I mentioned earlier, maps to higher maturation, premature maturation, which then post weaning from formula, the baby's diversity in adulthood seems to be lower. So there's some evidence of that correlation. And so how does kind of the feeding mode and the birthing mode kind of relate to each other? Well, actually, the feeding mode is more important than the birthing mode, right? Sometimes, again, we get parents coming to us feeling really sad or guilty about their C-section, and we tell them, well, the number one modifier of the baby's gut is birth mode. The number one modifier of the baby's gut post-birth mode is the feeding mode. In fact, there are papers showing that feeding mode actually shapes the microbiome more than the birthing mode. Because the HMOs continue to feed the healthy bacteria in the baby's gut and helps it bloom. So there is a really strong modulation factor. And if baby needs formula for whatever reason, medical reasons, or mom just chooses not to, there are supplements in the market with specific strains of probiotics, and you have to add a prebiotic, an HMO prebiotic, to mimic the breast milk environment. So there are things you can do strategically if you're formula feeding or you had a C-section. Doesn't mean all hope is gone. There are ways to modulate your infant's microbiome. The more important point here, again, not to, there's no guilt here. Everyone has their own choices and things they can't control, as I had my C-section. So it's all about empowering yourself with the data about your infant's health and your health, and what can you do about it to really improve and restore that microbiome. So there are ways. Again, you're not clear if you're vaginally born and breastfed your infant. As I mentioned, the caveat here is that mom's gut also needs to be in good shape and have those healthy bacteria that she's supposed to pass on to baby. So I'll move into the features of a healthy microbiome and how that differs between adults and infant. I already alluded to that earlier on. I'll repeat it a little bit more here. Again, in adults, you want high diversity because the variety and the richness and evenness of the species in your gut. And a typical adult may have 300 to 500 species. You can see all of those in a Tiny Health stool test. We have stool tests for adults as well. And in infants, you may see 10 at birth, and that grows to maybe 50 when you start solids, 100 over time. So it really is supposed to be low because, again, the only function of the baby's gut in the first 6 months is to digest breast milk. And so in adults, you want to see no E. coli type bacteria, no opportunistic pathogens, maybe very low, maybe 1%, 2%. In infants, you may start out with 70% E. coli type bugs, and it rapidly goes down with breast milk and bifidobacteria coming in. So you don't want no you don't want no E. coli. So remember, in adults, no E. coli is good. In babies, you actually want some. You want about 5 to maybe 10% to train your immune system. So sometimes we also get babies that have too much of a good thing, too much bifidobacteria and no E. coli type bacteria, Enterobacteriaceae, and we're asking the parent if they're over sanitizing, if they're exposing their babies to the nature or, like pets more. So it is actually healthy to expose the infant to some low levels of E. coli type bacteria. And I mentioned earlier, the guts are highly permeable. So you do want the protective bifidobacteria while exposing the baby to a variety of sort of like diverse bacteria, which from the environment, you'll get some E. coli, some streptococcus, and things like that. And the short chain fatty acids, that's really important for the gut lining of your immune system and your intestines. You want to see acetate in early life, in the first year of life, high. They're influenced by bifidobacteria. And then once you switch to solids, you want to see high butyrate function in older kids and adults. So I have this graph here to really show you. Remember, I said maybe an infant, we can see 5, 10, maybe 50 bugs initially. They're kind of like a barren island. And so the reason why the baby's microbiome is so malleable is because of this low diversity and these new bugs kind of like colonizing the barren island, right? Because it's barren, because it didn't have any microbes there to begin with. And then over time, you're getting more and more like coconut trees, and you want, the right combination of coconut trees and weeds. In early life, if you have too much weeds in the island, it's very easy to unweed and replant the island with the coconut trees. And in adults, as I mentioned earlier, it gets harder because at that point, it's a rainforest. So it's much harder to unweed the weeds and replant it. Again, possible, but very hard, right? You need to be very disciplined for 3 to 6 months in changing your diet, implementing a new supplement, and doing some lifestyle changes. I talked about gut maturation earlier and how we can predict microbiome age from birth to 3 years old within a 1 month accuracy. So I think that's pretty cool and groundbreaking from a scientific perspective, and that's now available to you. We're trying to chart that microbiome age between 3 to 5 years of age when the child's microbiome is moving to adult-like maturation, and finally, there's an aging microbiome as well that we're also looking to develop. So you want the maturation to map according to diversity and its due time. Too fast or too slow can be associated with deficits in the developing immune system. And so I'm flashing the Dogra paper again. We modified this graph a little bit to show you how it is really important to choose the right stool test for this age group in the first 1,000 days because of how rapidly changing these microbial families are. So we spent 2 years of R&D. So my son was born in 2020, and we only launched our products in 2022 because it took a lot of research and creating our proprietary bioinformatics to map how these rates changes. And we took a lot of public literature and data from published studies initially. And then now we have more and more samples from our own cohort. So 3-month-olds requirement for bifidobacteria is really high. Again, I mentioned ideally we want to see, frankly, 50 to 90% bifidobacteria. At 9 months, you would have started solids, and that requirement goes down to a healthy level of about 50%. Like Gray's typical. So you want that to be 90% at first 6 months of life, and then it moves down to 50%. And at 3 years old, with weaning, presumably that bifidobacteria requirement goes down to 10%. And in adults, it goes down even further to about 6%. So the reference ranges changes according to the mapping of the child's gut microbiome maturation. And then Enterobacteriaceae, again, your E. coli type bacteria, I mentioned, it is quite crucial to see some of it. So you see some greens here. We don't want it to be 0. We want there to be some E. coli. And the baby can tolerate high amounts of E. coli at birth. Like we see here being 32%, and then at 9 months moving down to 17%. And at 3 years old, we want to see less than 4.5% and even lower in adults. So the reference range for each kind of metric that we measure in our reports change over time. And this is really important to use the right test, because I think I did, and when my son was 2 years old, I did an adult stool test. And it told me that my son had 90% bifidobacteria infantis, and that was unhealthy when it actually is really healthy. It told me that his gut has low diversity, again, that it's not good when it's actually good. So that adult report was totally incorrect for my infant. And I would also encourage you to look for a shotgun metagenomic test. That's what Tiny Health offers. It gives you the full picture of every microbe in the gut. So not just bacteria, but fungi, viruses, or parasites, if you have any, archaea. It gives you the full picture of everything in the gut. So these beautiful microbial pictures here are the microbes, and then the dots are the functions. So HMO functions, short-chain fatty acid functions. And with, PCR tests has been in the market for a long time, and it has an important role in identifying very specific species targets, but it gives you a narrow picture of what's in the gut. So you don't know if that E. coli represents 0.1% in someone's gut. Is it 1%? Is it 10%? It really does matter in a child, and even, we believe, in an adult too. So it gives you a more holistic, shotgun sequencing gives you a more holistic of not just who's there, but what they're doing as well. So I mentioned here, it shows the relative abundance of all the microbes in the gut. We show a full list of everyone who's there, and then also what they're doing, the functional gene production. So in infants, you want to see HMO digestion, you want to see acetate capacity, and then you want to see the antibiotic resistance signature being low. You want to see C-section signature being low. There are many metrics that change over time. So an infant will get a different report from a 3-year-old or a 2-year-old and an adult. I'll talk briefly about bifidobacteria and HMOs. I've already talked a lot about it. But again, just as a reminder, 50 to 90% is what we want to see in infants under 9 months old. These are all the functions of bifidobacteria and why it's so important for their immune system. And we want to see 4 specific species. I promise you, I'll give you the species. We want to see B. infantis, B. longum, B. bifidum, B. breve, because these are clinically shown to digest the HMOs in breast milk most effectively. In fact, B. infantis is the MVP here because it is the most efficient out of all of these other bifidobacteria. Sometimes we see babies high in bifidobacteria, but they have the wrong kind of bifidobacteria. They have B. dentium, which is more an oral bifidobacteria, or they have B. adolescentis. As the name tells, it's supposed to only come later in life. We typically see B. adolescentis in older kids and adults, but if they are colonizing the infant's gut in early life, they may not be HMO degraders or acetate producers as well. And so we actually see some symptoms sometimes if they don't have the right kinds of bifs. So these species are actually really important to look for in a baby's gut. And then after weaning, the abundance decreases rapidly. However, it should not go down to 0, as I mentioned earlier. It remains an important player in a child and adult health. It still produces lactate and acetate, but it really aids the increase in butyrate production along with the solids intake and diet with healthy plant-based fibers. And it cross-feeds other microbes that are healthy short-chain fatty acids producers like Faecalibacterium and Eubacterium. Human milk oligosaccharides, I mentioned, moms actually have a unique set of over 200 possible HMOs, and the main families are the FLs, 2FLs, the SLs, and the L and Ts. And so this is, I mentioned, really important to feed the infant's gut. We can see that in our reports as well. For formula-fed babies, you can, thankfully, there are infant-approved HMO supplementation now. I just want to point out that the HMO, while you can supplement it, and now it's available in some formulas, the quantity, is very different, right? So there's about 10 to 60 grams per liter of HMOs in breast milk. And let's just say on the low end, the baby drinks about 750 mLs of milk a day. And if the mom had on the lower end, like say 12 grams per liter, that's about 9 grams a day that the infant takes through exclusive breastfeeding. And some formulas only have 1.3 grams of 2FLs per day, per serving per day. So it's better than none, but it's not a lot. And some HMO supplements also have around that 1.2 grams recommended a day. I'm not sure what happens if you increase it. It's not scientifically, clinically proven to be safe yet. So I would exercise some precaution. But again, sub HMOs is better than none to help the BIFs colonize. And it's not just for babies. There are HMO supplements now for adults. So, can you restore a missing bifidobacteria in an adult gut? And the answer is yes. I've seen it in myself. It's possible. I had no bifidobacteria, and that I did a BIF probiotic with an HMO supplement, and I did get it from 0 to about 9%. There are clinical studies showing this colonization. So there is hope for us adults who no longer have bifidobacteria, which is very sensitive to antibiotics, by the way. So then antibiotics. So I'll kind of my last 2 topics here are the off-course gut disruptors. I talked about C-section and formula feeding and how you can restore it. I just want to show this graph too. What else could be factors? I mentioned the first 1,000 days starts during conception. So you want mom's diet and nutrition to be intact there as well. And mom's pregnancy conditions like recurring UTIs or preeclampsia, GDM, GBS have a huge role to play as well. The mom's vaginal microbiome have a big role to play. I'll talk about that soon. So normally in this green line, if everything goes well, then their immune system is adapted to respond to all these allergens that you see. If not, If you have some early life disruption, this leads to immune-mediated problems like eczema, food allergies, asthma. We talked about that. Type 1 diabetes, Crohn's colitis, autoimmune conditions, other chronic conditions later in life. So this is truly something that I think everyone should pay attention to. Diving a little bit into the prenatal gut, with our pregnancy gut tests and our pregnancy vaginal tests, and I recommend people do it when you're trying to conceive, because as I mentioned earlier, it takes a little bit more time to modulate and change the adult gut and vaginal microbiome. It could be 6 months of hard work, could be 9 months, could be 3 months, if you're diligent, but it takes a while. So we have these predictive biomarkers for gestational diabetes. A lot of us Americans are walking around pre-diabetic, not knowing it, and when we get pregnant, it triggers that metabolic syndrome and GDM. So something that you can catch to see if you have those microbial signatures, to take action earlier on with diet and lifestyle interventions before you do the glucose test. So there are things to check out. We have predictive biomarkers for constipation, for UTIs, which again affects pregnant women more. So something to see if you need to do, if you can't do anything ahead of time, to be aware of it. PCOS, preeclampsia for women as well. So there's definitely some interesting emerging signs here that we can show you in your microbiome report. And then in the vaginal microbiome, which is very under mentioned, an unhealthy low lactobacillus microbiome, vaginal microbiome, is related to lower IVF success, which is a proxy for fertility. So, it is important to have a vaginal microbiome that has the right lactobacillus species. Again, the strains do matter, the species do matter. We want an acidic environment, and the lactobacillus species in the vaginal canal produces D-lactic acid that keeps the vaginal microbiome acidic and keeps pathogenic bacteria away. And so if the mom doesn't have any lactobacillus or an alkali vaginal microbiome, there is actually a higher risk for preterm labor. So you do want to check in if you're trying to conceive or pregnant, to see if you have a healthy lactobacillus dominant vaginal microbiome. You obviously also want to check if you have group B strep, and it's not just in the gut and the vaginal canal, it's also found in the gut. So you want to check both the gut and the vaginal if you have GBS, which again, most people are recommended to do antibiotic drips during labor. If you do have GBS, if you catch it earlier, then you can take action from a dietary perspective, adding more garlic and onions and ginger to your diet. You can take certain oral probiotics to decrease the risk of GBS. And then you have all the other usual vaginal disruptors. You can detect potential BV strains, potential yeast infection. So you can take action to reduce that risk during pregnancy and birth. I mentioned earlier that B. infantis is the MMVP, but most infants and most adults are missing it. 90%, as a paper that was published recently showed that 90% of infants in the US do not have B. infantis anymore. So, and we think that's because it's propagated by an overuse of antibiotics. I'll skip this slide a little bit. I talk a lot about the immune gut axes, and I talk a lot about how this leads to chronic conditions. What are early signs? Sleep issues, colicky symptoms, gassiness can all be linked to imbalances in the gut. And of course, eczema and allergies are a huge, problem facing our kids today. About 1 in 2 kids have at least one of these chronic conditions today, which feels really high, and the new normal is not normal. It should not be normal. And then this evolves into things like constipation and asthma by age 6. Lots of other chronic conditions in adulthood as well. And, I want to talk about a little bit about antibiotic use as well. 70% of children today receive at least one antibiotic prescription in the first 2 years of life. That is a stark number. And I mentioned that bifidobacteria, if wiped out by antibiotics, because remember, antibiotics may kill pathogenic bacteria, but it also kills beneficial bacteria if you're taking a broad spectrum antibiotic. So, so it depends on the spectrum, how widely it kills all bacteria and how long the course is for how well your microbiome can recover. And if children and infants, as their guts are developing, if they're exposed to antibiotics in early life, if you don't take care to restore those missing beneficial microbes, they may never come back. So I do think if there's one takeaway, you should take that away to be very judicious about antibiotic use. Sometimes it's life-saving and completely necessary, but unfortunately, most of the time it is not. Some studies here showing how what I mentioned earlier, kind of the amoxicillin associated with a complete disappearance of bifidobacteria, and even Archimandsia, which is important for metabolic health and gut lining. So lots of stuff here. And, the number one reason for antibiotic use in early life in kids are ear infections, right? 80 to 90% of children have ear infections before school age. And the other takeaway I'd like you to have is that most ear infections are actually viral, not bacterial. So it is important to ask your pediatrician if they know if it's viral or bacterial. Most of the time, if it's viral, antibiotics will not do anything to wipe it out. It will just go away after a few days. So it's tough. I've been there before. And you need tools. Alternative treatments if you do not want to give your child antibiotics. And this is not any medical advice. But I think it is important to really try to figure out if the source is viral or bacterial, and to see if there are other things you can do before that antibiotic use in early life, because just one dose of antibiotics can increase infections, asthma, allergies, mental health disorders, ADHD, autism, things like that, and obesity as well. Prenatal exposure can also influence baby's gut, GBS during labor. So babies are shown to have less Bacteroides and bifidobacteria if exposed to antibiotics for GBS, but it depends on the dose and the length. I believe under 8 hours is okay, but anything above 8 hours, you are at a higher risk. But there is hope. There is a microbiome recovery. As I mentioned, baby's gut is very malleable, but you do need intervention. You need intentional intervention. As I mentioned, it's malleable during this critical window. It requires a paradigm shift. And I promise this is my last section here. So I think the paradigm shift that's taught to conventional, maybe practitioners and even functional practitioners, is that when we see pathogens in adults, we want to kill, we want to reduce, which is rightfully so in adults, for sure. In most cases, not all cases. But in babies, again, remember that reference range, babies can tolerate a high amount of pathogens. And the strategy here, and most of the time, they have high pathogenic bacteria because they're lacking beneficial species. They're lacking the bifidobacteria that should be there in the first year of life. So the strategy should be to crowd out the pathogenic bacteria by boosting bifidobacteria. And we've seen so many babies successfully do that. 90% E. coli at birth, and with the right probiotic, the right strains of probiotic and prebiotic, the next sample, we're seeing 90% bifidobacteria, and symptoms go away. Can't promise anything. This is not a cure, it's not a treatment, but it is a strategy to course correct an imbalanced microbiome in early life. So antimicrobials, even herbs, are not necessarily the answer to dysbiosis, especially in babies. I would not recommend strong antimicrobials, definitely not antibiotics if not necessary. You can decrease pathogenic bacteria by increasing beneficial species. Again, this paradigm shift, because it's so important. So instead of focusing on kill protocols in early life for kids, even I also think like 3 to 5, maybe 5 and above, I'll be okay with that. But instead of the kill protocol, focus on rebuilding beneficial microbes to compete with pathogens in a healthy way. So where to start? We like the term test, don't guess with technology today, and it's pretty affordable. You only get this microbial mapping once in their life, you kind of want to preserve it. If you are capable and can afford it, why wouldn't you want to see what that baby's microbiome is in early life and how it changes over time? So in the first 4 years, in the first year, I would recommend, if you can, about 4 tests once every quarter in an infant's gut over that first year, and then post 1 year, maybe about every 6 months. Even in adults, I proactively do it every 6 months because moving, new daycare, new environment, travel can really change your microbiome. It's good to see that baseline and how different environmental factors change your microbiome over time. Functional, again, I want to say that it's not enough to know who's there. It's really important to know the functional part of it, what they're doing, and are they functioning as intended. And then, of course, using appropriate reference ranges. So even our maternal pregnancy tests, the reference range for first trimester is different from third trimester. And it's important to use that reference range. I talked about boosting friendly gut commensals first to crowd out unfriendlies. Maybe I'll mention here diversity in diet. Fermented foods are more impactful to increase diversity. Fibers are too, but fermented foods consistently every day is key. Digestion, hydration, exposure to nature and pets. And sometimes we get parents telling us, well, I'm already doing all this, but I'm like, well, we used to spend 90% of our time outdoors and 10% indoors, and now it's 90% indoors and 10% outdoors. So our perception of how much we're spending time outdoors is really not the same. It's really not enough, and we need more. And avoid over-sanitization, avoid toxic chemicals, hand sanitizers that, your kid may then grab a snack and eat and ingest may not be the best for their gut health. And then pre-probiotics, we actually don't believe that every infant, every kid, every adult needs probiotics. It really depends on your gut function, what's deficient, what you need. Depends on symptoms, right? Some probiotic strains, they all have different functions and different indications. So if you're not using the right strains, it may cause more harm than good. So you should first understand if you need the probiotic to influence and shift the overall composition of the infant or your child, or do you just need it to support the symptoms and conditions? So different use cases. When do you use single strain? When do you use multi-strain? Strains do matter. So strains are these letters and numbers behind a species. If you only see the species name without letters and numbers, I would usually not recommend buying that probiotic because the strains drastically influence the functions of the bacteria. So we know from research, Rhamnosus GG can help with eczema, against symptoms. They help with symptoms. They don't help change the community. You need the bifidobacteria to shift the child's community. So it's important to understand that. B. infantis has been shown to help reduce G. navis. Ruminococcus navis is a bug that is most of the time indicated in atopic March kids. And then there are certain strains like Longum BB536 that has been shown clinically to help with elevated B. fragilis, to lower that specifically. So, and then colic and, mastitis, like most people sometimes jump to antibiotics to treat mastitis, but there are actually specific strains of lactobacillus probiotics that can actually help reduce the risk of mastitis or help treat it, in fact. Feed them well. I mentioned prebiotics, so HMOs are essential in early life, but there's now HMO supplements for adults too, but nothing beats whole foods, right? So eat the rainbow, fruits and vegetables. We have a really nice nifty chart here telling you what functions some of these vegetables and fruits influence. You can download it from our portal. And again, fermented foods, and then avoid emulsifiers because they do impact the gut microbiome. Digestion, slow down and chew food well. It starts with eating habits in your child or in yourself. And antibiotic strategy. Again, if antibiotics are needed, and sometimes they do, be aware that it's going to deplete your bifidobacteria and probably Archimandsia. and an organism may temporarily spike post-antibiotic use as an immune response, and then go back down. So you can use probiotics and prebiotics alongside antibiotics to buffer the damage. Saccharomyces boulardii and Bacillus clausii has been shown to help with that. And then you'd want to consume a variety of prebiotic foods to support your microbiome, and then test afterwards to see what's missing. Ideally, you have a baseline sample before antibiotic treatment, and you see how to restore it after. And again, bifidobacteria supplementation may be needed along with HMOs. And then the household I mentioned earlier, how do dads and older siblings influence the child's gut? They do. So in some cases where we see mom not having any bifidobacteria and infants magically had it. And when we do have dad's sample or older sibling sample, dad had it. So, it is actually really profound. So that's kind of like doing skin to skin time with the infants at birth and early life, kissing baby, sharing food. They can pass on their microbes to baby too. So if mom doesn't have it, don't fret. Dad, can also come in to help. So it's not all just the weight on the mom. Older siblings, if they go to daycare and they get some from their friends, can bring back this healthy microbiome to infant as well. Of course, the flip side is also true. They could be bringing back pathogenic bacteria. So you do, again, want to check that your infant has the protective bifidobacteria. Mom's gut, vaginal, I think I already mentioned this, should have one of the four HMO degrading bifidobacteria, the core four that I mentioned earlier. Her gut should be high in diversity and butyrate function. Butyrate function during pregnancy actually influences the baby's brain development and behavior later in life. Mom should have no to low levels of pathogens and low risk of GDM, preeclampsia, UTIs, and so on and so forth. Mom's vaginal microbiome should be lactobacillus dominant to produce an acidic environment. Ideally, we want to see L. crispatus dominating the mom's vaginal canal. And this is connected to lower risk of preterm labor and vaginal infections. And again, we don't want to see GBS in both the gut and the vaginal canal. And so if the mom's vaginal microbiome checks out and is good, and if you happen to need a C-section, perhaps then she can be a candidate for a procedure called vaginal seeding or vaginal swabbing. Again, it's not formally approved by ACOG, so use it at your own discretion. It is something I personally researched and did with my C-section child, where within 2 minutes of my daughter being born by a C-section, we took a gauze that we put in my vagina for about an hour during the operating room prep, and we swabbed it when she came out, her mouth and her face, to mimic the vaginal process. So there's been a couple of papers come out that some showed good evidence of C-section babies looking like vaginally born babies, but the studies are still mixed and more research needs to be done. But we are hopeful that this procedure will yield good results. I briefly touched about infant oversupplementation. So, why don't we just give all infants a B infantis probiotic? Well, remember that the infant gut is highly malleable. And so if baby had indigenous strains from mom's gut or breast milk, you don't want to crowd it out, because the HMOs, again, there's 200 types of HMOs in mom's breast milk, we think is uniquely mapping the bifs that comes from mom's gut. So the supplementation can be very strong and can push out the native strains. And we don't know yet what that means and if that's the healthiest for baby. Of course, if baby didn't have any bifs to begin with, then you probably need some supplementation, but we think that native strains are always good. And then when you do introduce solids at 6 months, you want that natural diversification. We've seen some parents giving their infants probiotics for 5 months during that time period. And what that probiotic is doing is suppressing that natural diversification and maturation. And you don't want that either, right? You're kind of suppressing diversity, which is not good. So it really is important to be specific. And that's why you test and you don't guess. I think I'm out of time, but this is basically, it concludes my presentation. And I hope we have some time for questions.
Welcome to Rupa Health, the best place to order, manage, and track results from over 30 different lab companies in one single place for free. It's going to take you under 2 minutes to sign up, and you can order any functional medicine lab for your client in under 30 seconds. Let me show you how it's done. So here's our beautiful interface. I'm typing in the name of my client, selecting the lab that I want to order for them, and hitting send. From there, Rupa and their amazing team handle the rest. They email the client, collect payment, and even offer an interest-free 3-month payment plan. We've also built the world's largest library of information about chronic health conditions, the lab tests that can help you find the root cause, and the evidence-based interventions that you can use to help people heal from them. It's called the Rupa Health Magazine. There, we have in-depth articles about almost any health condition you can imagine. And we give you step-by-step protocols that other clinicians have used to help their clients heal and that are verified by evidence-based sources. You should totally check it out, and it'll transform your practice. And we can't wait to see you. So make sure you sign up today at rupahealth.com.